Hi, I am Rosaline Ha from IT21OG. So welcome to my channel. So first, from this video, we have to do a tutorial blog, which is for you to have some knowledge from us who are who are learning from Ninet Academy Cisco. So from this blog, we have to answer all the activities that we have in here in chapter 5. So from the chapter 5, which is the Ethernet. So I think let's start to answer all of these activities for us to understand all of this. So let's start. So first, from the first activity from the chapter 5, which is MAC and LLC sublayers. So there is a hacker characteristics. So we have to identify what is part of the MAC and LLC. So first, I will explain to you what is MAC. So the MAC constitutes that lower sublayer of the data link layer. MAC is implemented by hardware, typically in the computer NI, since specifics are listed in the IEEE 802.3 standards figure. So the LLC or the LLC sublayer. The Ethernet LLC sublayer handles the communication between the upper layers and the lower layers. This is typically between the networking software and the device hardware, or the LLC sublayer takes the network protocol data, which is typically an IPv4 packet, and adds control information to help deliver the packet to the destination node. So the LLC used to communicate with the upper layer of the application and transition the packet to the lower layers for delivery. So from the hacker characteristics, the controls the network interface card through software driver. So it is from LLC. Works with the upper layers to add application information to delivery of data to higher level protocols. LLC. Works with hardware to support bandwidth requirements and checks errors in the bit sent and received. MAC. Controls access to the media through signaling and physical media standards requirements. Support Ethernet technology by using CSMA or CD or CSMACA, which is MAC. From the last, which remains relatively independent of physical equipment. LLC. So let's check it. So this is all from this activity. So the next activity is the identify Ethernet frame field names. So I will explain this all before I answer it. So we start with this preamble and start frame delimiter fields. So the preamble or 7 bytes and start frame delimiter or SFD, also called the start of frame 1 byte. Fields are used for synchronization between the sending and receiving devices. These first 8 bytes of the frame are used to get the attention of the receiving nodes. Essentially, the first few bytes tell the receivers to get ready to receive a new frame. So, from this, the second one is destination MAC address field, or the destination address. This 6-byte field is the identifier for the intended recipient. As you will resend, this address is used by layer 2 to assist devices in determining if a frame addressed to them. The address in the frame compared to the MAC address in the device. If there is a match, the device accepts the frame can be unicast, multicast, or broadcast address. So the second one, which is the source address. So this is a 6-byte field identities the frames originating NIC or interface must be a unicast address. So the second one is the frame check sequence field. The frame check sequence or FCS field for bytes is used to detect errors in a frame. It uses a cyclic redundancy or CRC. The sending device includes the results of a CRC in FCS field of the frame. The receiving device reviews the frame and generation a CRC to look for errors. If the calculation match, no error occurred. The calculation that do not match are in indication that the data has changed. Therefore, the frame is dropped. A change in the data could be the result of disruption of electrical signals that represents the bits. Then let's have answer this activity. So, as I say, from uses pad to increase this frame field to at least 64 bytes is this 802.2 header in data. So from the describe which higher layer protocol has been used, which is this is the type, and the frames originating NIC interface MAC address, which is this the source address, assist the host in determining if the frame received address to it, and this is the destination access, notifies destination to get ready for a new frame, and this is the preamble, synchronize sending and receiving devices for frame delivery, which is start of frame delimiter, and the text error in the Ethernet frame, which is frame check. So let's check this one. So this is for this activity. So the next one is, so this is the last activity for chapter 5, which is the frame forwarding methods. I read the instructions. So description of switch frame forwarding methods are provided in the table. Just click in the store and forward or cut through fields to match the methods to the description. So this is the description, and this is the, so I will explain this, which is store and forward and cut through. So the store and forward switch receives the entire frame and computes the CRC. So if the CRC is valid, the switch looks up the destination address, which determines the outgoing interface. The frame is then forwarded out the correct port. So the second one is the cut through, which is a cut through switch forwards the frame before it is entirely received. At a minimum, the destination address of the frame must be read before the frame can be forwarded. So let's answer this activity. So from the description, buffers frame until the full frame has been received by the switch. So from this is store and forward. Check the frame for errors before releasing it out of its switch ports. If the full frame was not received, the switch discard it. This is store and forward. No errors checking on frames and performed by switch before releasing the frame out of its port. This is cut-through, and a great method to use conserve bandwidth on your network. Store and forward. The destination network interface card or NIC discards any incomplete frames and using the frame forward method, which is cut-through. The faster switching method but may produce more errors in data integrity before more than bandwidth may be consumed. Let's check it. So this is the last activity for chapter 5. So thank you for watching.